Hello everyone, I hope you're fine, and I hope that for those who are able to go to vacation, I wish you great vacation, guys. And also for those others who went to Black Hat or DEF CON, I hope that the event was great. And now let's continue to talk about these things, right, Clipper? I'm glad you like it. I was actually triggered by one of the, and probably also maybe two tweets from Lab 4.1 explaining that with new updates, some other things will change. You could see also that, for example, 2 hours ago, there was like some nice news actually about Flipper 0 having an AFC emulation improvements. So let's see, ultralight notification, okay. And also some fixes on the ways also for Subghz to add new protocols as well. So basically I wanted to make a second video about Flipper 0 because there's like some updates, but also I wanted to fix a little issue that I've introduced in the latest video when I was like trying to capture any raw data over there and I didn't press record, and some people just spotted it, and thanks to you I know how to use it. And I can actually thank Nemanja Nedeljković, who actually pointed out that I didn't wreck in reroll for Subghz. So before we start, we will first update this little device and then use the Subghz features, then see if the RFID features is fixed finally, because if you remember, we couldn't emulate anything. And then we'll see other things. Yeah, let's maybe just like fire the same software that we have run to update it. So just start that. So I will also go to download like that, and then go to KFlipper like that. Yeah, okay, a new version of the KFlipper will be installed. Let's do it. So yeah, it's been maybe like a week that I didn't run it. So yeah, let's maybe just update everything. And so then I will also just plug now the device in here. So we'll just plug the device like that. Like that. Now we see that the little flipper is sleeping, so it's the perfect time to update everything. Let's do it. So we will just now make sure that it is plugged in the device. We see that the build update was the 30 July 2022. So yeah, install SD card, everything is right. We update it. Let's press update and see what are the new things, what are the new cool features. Because I didn't have any time to actually work on it, maybe there will be like some cool features that are coming in the update. So yeah, let's hope that it will change our life. In the VM, we can continue, and now, yeah, now we have a fresh install update. So yeah, actually very fresh because we are in the 15th of August right now, and the update was on the 13th. So perfect for us. Let's see what we can do. So let's press OK. Yeah, nice. So we'll just look at the new features that are coming in here. So you remember that I was like actually trying to record a little remote. So we'll try to record this little remote and see if we can actually replay it against a light. So let's see that. So as you can see, it's a little bit dark in here, and I just brought a little light in here in order to light up everything in this room. And so let's see if I'm just pushing this button and then pushing the off button, normally it turns off, on again, off and again, you know. I'm just playing with it right now, but I want to actually record this little remote, which worked on the 868 megahertz, something as such, but probably we had some sort of an offset that was not good, because as you remember, we had some predefinite frequency that we needed also to extend manually before. So let's see if the update fix the issue or allows us also to dynamically change the frequency. And also something that the developer, one of the developer also figure out but told us on the YouTube channel is that probably things may come also from the deviation. It was also nice to see Subghz suggesting that we need to also, first read the theory, which also is great, and also to begin with the AM, precisely the ASK modulation, because you just do a simple amplitude modulation, and then to add our own frequency, there's like this part. Alright, so let's test this read row feature first and then see the others. So now I would just like try to press on and off and try to record them and replay them on this little light, as you can see in here. So yeah, basically we'll test that. So like that. So first I will just like to read row frequency. So let's maybe use this frequency, which is this one. Okay, it's not very flexible. So yeah, we'll just test that like that. And then it's probably FM. Yeah, actually I didn't dive into this. What is the difference between FM 238 and FM? Probably maybe the, I don't know, maybe the bandwidth. I don't know actually what is it, because it's, maybe I have to also read the documentation. So let's do that maybe later, because we don't like to read, right? Back. So let's go back like that and see. Okay, so you can see now we have something. That's nice. Let's do some recording of the on feature like that, and we stop. Then we'll just like resave. We can save it also. We can maybe see what is saved. But first, I will just turn off the light, which is in here, like that, as you can see. And I can maybe, I think that you can see it from there. You should see it like that. And so now let's maybe send. Okay, nothing happens. Probably because we are not in the exact frequency. And probably I have to modify this. But that's weird because I thought that they probably also give us like the possibility to add. Yeah, let's try maybe with the FM 476. So maybe I will have more chance. I will just like that. Like that. So several pushes like that. As you can see. Okay, let's try. And it's, yeah, still nothing happens. I think it will end all right. The other targets that I have, for example, like a dumb alarm that I have also in here, I can also give you the test of this, of the replay, because it's just like a matter of replay. There's like no protections, no security mechanism in these buttons. So the same buttons, you will only have the same button push without any rolling code on that. So maybe just to reassure you that it is working, let's see with another target. Alright, so I've just changed my target to an alarm. So yeah, let's use that against a very simple ASK OOK signal. So it looks as follows. I have a remote, and these remotes can actually arm and disarm the alarm like that. So maybe I can also maybe zoom on the screen. So you will be also able to see that I'm not cheating. So basically, as an attacker, what you want to do is to disarm the alarm. So as it is a French language alarm, here we are in the armed phase. And then we have désarmement. Bonjour. A désarmement, which means disarmed. So yeah, basically as an attacker, you can then come to the house. So I will record it with the flipper 0. I will record one of the push that is in here, and then we'll see if the flipper 0 is able to handle it. So I'm back to this device. I will erase these things, and I know that it is using ASK, so I will also configure everything like that. I will use ASK like that. So yeah, first AM, so let's maybe use this one. Still, I don't know what is that, but let's see that a bit later. I will probably just run the documentation, open the documentation with you and see what is it. And so I know that the signal is somewhere in here. Precisely. If I remember correctly, it was that. So then I will just like press rec and record the disarm command. Yeah, it's nice. I can see it is recording. Super. So it's disarm, right? Now I'll just put the alarm with the remote that you see in here, this little remote. I will put it in armed phase. And so now let's see, it's armed. We'll send now a signal. So we'll just send that. Oh, it changed. Perfect. So yeah, these raw features work. That's cool. Probably to get it work with this remote, we have also to find the right frequency offset for that. So maybe we can use this frequency analyzer. That's a little bit dumb, but yeah, you can actually maybe see some frequency around the 868. And so we'll probably have the right frequency to work on. So let's see that together. I will just like do some pushes and then we'll try to spot it. We just erase that. We'll just go back. We go to frequency analyzer like that. And so now let's see. Yeah, okay. It's not super stable, right? I don't know which one to choose. Okay. Okay. Yeah. Yeah. I'm still pushing, but it's not super easy to actually see which frequency to choose. And I cannot actually change the frequency dynamically. I thought that I could. I'm just like looking at the YouTube channel. Scorpion said that, let's see, in here, like that, in the latest version of the attachment, support for custom presets has been added, where you can configure the CC module as you need. Okay, maybe I have to find where this little feature, where it is actually. So let's see. Apparently I have maybe 2 issues to actually investigate, but first let's maybe save this sample. So I will just now go back in here like that and see what is going on. So we just save some samples right here. Let's go in here. Raw signal, nice, super. I'm super happy. Read row, configurate, not that, erase, configurate. Okay, I will try with this frequency at least 45 FM. Let's use this FM. Rec. Okay, save. Let's call it raw signal 1. Okay, perfect. And then let's see if we go back in here, file, SD cards, gigahertz, raw signal. Let's download it. Okay, I will probably download it somewhere else, like in here. Okay, so now I'm going, let's use maybe xdump on that, and then it's raw signal, right? Just a raw signal sub. Okay, it looks like that. Perfect. So we have decimal values. Seems. Okay, okay, it's some sort of a format that we have also. Let's see. Yeah, I forgot desktop. Okay, so yeah, okay, I have that. Okay, so yeah, looks like I have some decimals in here, so I have to actually convert these decimals to have something. So you have like overall data. I can, for example, use Subghz in order to convert the decimals to eggs. So like that, I have a nice value. So let's do that very quickly. Subghz, and then yeah, from decimal, run decimals like that. Input. Okay, it's not decimal at all. And if you look at the forum, it's something that's a kind of a format I don't like actually, because it tells you that if it's positive, it is enters at the end. So if it's positive, it is 1, and then you have the duration. If it's negative, you have a duration of a 0. So yeah, basically here the format is well described, but that means that I have to actually do 2000 repetition of 1. So yeah, at some point it is compressed. It's good because the format also gives you a nice compression at some points. Yeah, I think that it will also take too much space. It avoids, for example, to have all the repetitions, etc. So it is some sort of a compression. So we take back our file, we will just take this things like that, and we'll then use Python like that because we like Python. Then we'll do these things. We can just like copy like that, and we just try to split everything. So split like that. Okay, so now we have a table like that. That's perfect. Now we'll just create a new table, for example, with all the interpretation like that. Basically, we just redo everything, and we just creating a new list with the representation of the P lists actually for X in P like that. And so we have P like that. I would probably also make like a M2 that will also give us all the hints, but without the symbol. So we can just examine it. What is the minimum amount of symbol, 1 or 0? We don't care about that if it's 1 or 0. We just want the minimum amount of samples, which also gives us about actually the bit stream that is used for each symbol. So we'll now use the 241. So let's maybe work on that. What I will do is that I will create a new string like that. So then I will decode everything like that. So I will just like do like for I in M actually, because it was M. So now it's like if I is lesser than 0, let's maybe say that we just want to fill the S with zeros at least. And we do also int, also abs, because you will have also some negative value divided by 51 like that. Okay. So should be good. Yeah, we'll see. And if I greater than 0, we do actually the reverse. So it should look like that normally. Now let's pray and see. Yeah, okay, now we have something we can work with. We can go with server chef and try to decode this in eggs. Normally up like that. Server chef inputs from binary, because we are lazy, from binary like that, and we can maybe just go to eggs. Like that we will have the eggs representation. Okay, so we can probably work with that, and it seems that we have some repetition at some point. Wait a second. Like maybe we have some sort of preamble, we don't know actually. We'll see that with maybe your reg directly. So yeah, it's F genre FC. Okay, so yeah, I will probably just try to decode it with N, so we'll see what is the problem. So it's well centered. I can now close it and I can record the signal. I'm recording the signal right now. The open right up. I can then decode it. Yeah, let's decode it in here. Doesn't matter. And yeah, actually everything should be good. It's FSK, right? So it looks perfect. I will probably just use the spectrogram in order to just clean a little bit all of that around. Yes. And then auto detect parameters. So yeah, like that. I'm cheating a little bit, but okay. So I have now 100. Okay, so it looks perfect. Okay. But if you compare the input with what we got decoded from URH, it doesn't look anything like that. Even if you just compare the bits, it's not like that. So apparently there's like probably something with the deviation at some point. But basically, yet if you try to use another FM demodulator, you get another result, but not something that will actually work. So yeah, I think that there's like still some work to do around maybe this demodulator at some point. Let's see. And if you look at the source code precisely, it's probably what we thought about it earlier. The dev, the number just after 238 is probably about the deviation. So that means that the space between the mark, the bandwidth, the length between the mark and the space of the FSK to FSK is actually that, and we have a bigger like that. So yeah, if you just try to look at the deviation in here with your range, let's look at the deviation. So if we push that, wait a second, I forgot also to just use the control panel at some points. Okay, apply like that. Let's see. So I will do like a max odd and see about the deviation at some point. I'm well centered normally, but I should have something like, yeah, 19, minus 19 or minus 20. Let's say 20 kilohertz deviation. Okay, not 20 kilohertz deviation, but 40 kilohertz deviation. It seems like we have to set up that in the, I will find something about it like that. Maybe I will have some chance. Okay, I see. Now we have some comping in here. So I can probably just configure it. The header, I don't know. So what we have in here. So what I will do is that I will probably just like configure it directly the value of the deviation in here. I don't know what was again the reg. Okay, let's see. Okay, this is the reg for that. Okay, so it's our CC 1101 configuration. So yeah, it's pretty creepy. I really don't like this kind of thing. A modem configuration, format UFSK, no preamble, data rates, okay, boards, deviation is that. So normally I should also look at the deviation, the possible deviation in here. It's good to probably go to the documentation of the CC11. Yeah, okay. Smart, no. Deviation. Settings. Is there like any documentation directly, specification documentation about that? Okay, it is that. Okay, yeah, but it will not talk about the regs. I'm interested about the deviation, okay, it's deviate 10, okay. Deviate 10, okay, so it lets you, so let's maybe just do a little Python script in order to process that, and we just do Python. So the ftf is equal to 26. Let's say that's using the same crystal, I don't know, so 6 divided by 2 by a second, it's O2, like that, let's say yes, perfect. Yeah, I wasn't sure. O2, then like that, multiply by 8 plus, here the deviation is 7 in here, then we have an exponent, right? The exponent is 4. Yeah, 4, 2 to 4, like that. And what is fdev is that? That's okay. So 47. So okay. So we have exactly the same number. We just like, I'll just like maybe show that directly in here. Yeah. Normally, if I'm just like decreasing that, I will have that. We use the same exponent. Like that's not much surprises, but I will just lower that a little. Or I'm just brute forcing all the things. 5, yeah, let's say 5. I mean 3. Yeah, the exponents matters a lot. So 5 should be like something more in the range that we are trying to get. Let's see if that works. Normally, if you're not exact on the deviation, generally does not matter too much. Too much deviation is too much, that's normal. But in here we are very close. So yeah, normally shouldn't be like too much a problem. But let's see. And what I will do is that I will directly use this parameters, so deviation m to these registers. So now I need to configure it in here. 47, so 47 is in here, deviate that. So you have the exponent in here. We just press 5 like that. And yeah, let's pray. I will directly integrate the source. I'm doing that in a very messy way, but I'm lazy. Please forgive me. So yeah, I will just, because as you can see, there's a lot of parameters. I don't want to make a whole function. Just want to directly see if I can work on that directly. 45, and yeah, 45 is actually, sorry, 45. I'll probably just leave some comments at the end of my modification, like that. So we have that. So now let's see. Let's pray, and we'll see if it works. So I will just like now make a new firmware out of that, and then we'll see. And actually, I don't know actually what is the good frequency yet. I hope that with the one that I've preset, it will work. But yeah, as you can see, it's a little bit fuzzy. All right, now it's finished. We will try to flash now the device with this firmware. So let's go to build like that. Normally to be on the build dev. Okay, so let's see. I will go here, insert from file, like that. Yeah, the GUI is broken in this VM, like that. Sorry. File, okay. We'll just go back in here now. Flipper 0, build like that. Yeah, okay. Where's the dev file? Install. Now let's pray. Okay. So now let's see. It is working. Continue. And I will just like do some retries in order to move the lights. So let's try it. I will go to Subghz. Once again, redraw. And on the frequency, that is the closest to the one that I've seen. But yeah, I now will use FM this one. Because now we know that it is relative to the deviation. Actually, for AM, I think it is probably maybe the bandwidth, because in FM you have the deviation, in AM mostly the bandwidth of the modulation, the amplitude changes, etc. So you can see on the FSK the same thing, pretty the same thing. It will be just one spike in here, display 45 like that. So let's pray. I think if it doesn't work, I don't know actually what what is going on, but I know that CC1101, for example, and all the CC11 families is awkward, and not awkward, but let's say complex to actually set up in the right way. Okay, so let's try. I'll just do like a bunch of presses, so like that I'm sure that everything would be good. Just do that, and so not touching the screen, we'll just touch the screen right now. Let's pray. Oh yeah, that's work. It works, man. So that was the deviation actually. Yeah, the deviation also was probably the reason that Scope actually mentioned, is that yeah, still you can mess a bit with the deviation, but not too much. And so in here I was exactly in the right frequency. I was using a deviation which was more closer to the one that was used, and now it works. So yeah, so now we see that it works, and we see also the problem, and so that means that we need actually, maybe it would be probably better to have also in the GUI a way to set up the deviation. Let's now look at something that didn't work before, the MyFair Classic emulation. So if you remember, I had a tag like that, and I wanted to copy it with the Flipper 0. Let's do it. Let's do that. So we just go here, and we put everything in here like that, so you can see also in real time what is going on. I will now go to option, not LDC, plugins, blah blah blah, button. No, see, it's the right thing. So I will just like now read this little tag. Normally it will brute force keys very quickly because it is using the default keys, the first default keys that are FFFF. So now we'll go to more, emulates. Okay, so let's try to emulate that. Okay, so now let's maybe just put Flipper 0 and see what is happening. Okay, as you can see, it's super jumpy. I'm trying to use one of the tools in here. And even if you try to run it against a real reader, it will not work. Alright, so basically we have been able to see what's actually the different modulation were. Now we know that it is the deviation. We know how to push also some arbitrary frequencies in order to decode, or if you want to scan. So that's great. And also to read in RAW. And yeah, basically that's that. We know that now we need for the deviation, if we want to adapt the deviation at some point. As far as I know, there's no way to use that dynamically. All you need to do if you want to adapt, for example, the deviation for the Flipper 0 to another device, or you will have to patch it by yourself. So that means that you have to actually tweak the configuration of the registry of the CC1101 chip. and then rebuild all the firmware. You cannot do that dynamically directly. So this is a little bit disappointing because you have a nice look with some buttons. At least it could be good to have a way for to set up the deviation dynamically with those buttons. But yeah, for the moment it does not exist. Maybe they will think about that later. So I hope so. This is maybe an improvement to do. But yeah, and also we tested again the RFID, the NFC precisely when trying to emulate a MIFARE classic tag. It didn't work, but yeah, maybe they will be able to do that later. Let's see. But for the moment, I don't know. Actually, I didn't investigate it so far on that because yeah. Also, maybe I had probably spent too much time now on the Subghz things, and on the MIFARE, it could be maybe the response of the tag and the simulation of some answers. Or could be also the timing. I don't know actually, but yeah, obviously when I was trying that against a real reader, it didn't work at the end. My expectations were maybe too high on that. So basically today, do I recommend it for any pen tester or any red teamer? Probably not, because you will probably spend a lot of time, as I said before, trying to debug things. But still, for vacations, could be like a nice toy. Still, it is a toy, but then I think that a lot of people in the community will do like a lot of awesome plugins and also fix a lot of things around that. So yeah, I expect that it will also be improved a lot in time. But for now, you have to keep in mind that if you want to test it against real product today, you will have to investigate much more, because it does some basic stuff. I see a lot of people, for example, in YouTube, emulating things, also replaying some signals, etc., testing their cars against. But yeah, for some other variants, sometimes it doesn't work and you have to tweak it by yourself, or sometimes it is not supported. So yeah, for the moment, just take it as a toy where you can just like develop things, or you can improve things. But I expect that maybe not far away, maybe in a year, it will probably just do some very great job. But yeah, today, if you want to use that as a pen tester, you will probably like face a lot of blocking issues. You will not be able actually to inspect that, because with this screen you don't see nothing. You see nothing. So basically it will be complicated to debug, and then also it will take a lot of time to debug. Yeah, just expect some debugging time if you want to work on specific things. Of course, on the very simple, very basic stuff, you can already play with it. But yeah, if you're just working with a lot of IoT stuff, a lot of radio communication stuff, RFID, etc., it's still some improvements are needed for that. So this is it. I hope that you like this video, and also remember that you have to subscribe to this channel and also bump the like button. Thank you very much, guys, and see you later. Bye bye.